Hey, hello, good morning. We are going to use only the share screen one. So, can you hear me now? Sorry?
Yeah.
It's hard to hear you. Can you get closer to your microphone?
Okay.
Just for this part?
Sure. Okay, can you hear me now?
Oh, that's better, yes.
Okay. We're only going to use the share screen option, so please tell me if you can see it right.
Yes.
Okay.
Yeah, it's gonna have like an integrated video.
Yeah, sure.
Okay, yeah, it's a little it looks choppy.
Yeah, it's a bit of a delay.
Okay, let me see if I can fix that.
No se ve mi compañero.
Yeah, no, it looks better when they're it's small. It's a smaller picture.
I think you have to see it better now.
We're seeing the share screen and the videos in the lower corner.
Can you see it now?
Yeah. So you've got 3 screens.
Yeah.
Are they going to be using a microphone, the one that you're where you are? Or are they?
Yeah, let me see if you can hear them.
Hello, can you hear me right?
Yeah.
It's far away, but just have to make sure that you speak loudly.
Okay, yeah, sure, we're going to do that. Thanks.
Okay. Okay. Also, we're there's a slight change in the order. It's okay. You're going first.
Yeah, we're on something else. No, we're fine. Don't worry.
Yeah. Okay. Thank you very much for that.
Okay.
Okay, Shannon. Anything else?
I can't think of anything right now.
Yeah. No. Okay. No. I think you're good. They got control of it, so I think.
Yeah.
I think you're good.
Okay, so thanks. Anything I will be
Yeah.
doing.
Thank you.
¿Desconectaste tu cable de internet?
Sí.
¿Por qué?
Porque estoy viendo lo demás.
Dania, are you ready to try and check your audio video?
¿Qué te iba a decir?
Even if you're not quite ready to start the presentation, if you want to just turn on your video, we can bring you in. Okay, not yet, got it.
Sí, tengo que prender las luces, güey. No se ve nada en el test. Se ve muy oscuro. Ahí ya se ve.
Sí, está.
All right, Shannon. I'll be back in a minute.
Okay.
Ya te puedes volver a clicar, ¿eh?
Sí. ¿Qué hacemos con el audio? Dice que no se escucha en el Zoom. Bueno, por lo que digo. Se escuchan muy feo.
Muy lejano, ¿no? Pues que pongamos el micrófono aquí.
No voy a llegar. No son bastante los más expansores.
Deben estar igual ahí, pero este es el otro disco. Que deben estar en el mismo lugar, pero ahorita los busco.
Yeah. So like we can leave your let us know how to coordinate the cameras if you're all going to be using the same cameras at the same time. You need to turn off the audio completely on all but one. Keep working in the background. We bring you in for the opening and we'll do a team introduction. And then when the other teams are presenting, you can continue working. And don't worry too much. We still have the video, correct, Elmer?
Yeah.
Okay, so, I mean, we know this happens and it's unfortunate and it'll be okay. Okay, so yeah, we'll put you last.
Yeah, this is the only camera you'll be using?
If it's okay, share screen. Oh yeah, we're gonna be using one camera and sharing screen as we put it.
Okay, on the same camera or a different one?
No, a different one. A laptop.
Okay, can we test that one as well?
Okay,
Alright, I think I fixed the audio.
Awesome.
Great, get up here. Take it up here. Can you see all of us?
Yes.
Both of us?
Both of you, yes.
How much of this supposed to was? Oh, not enough, yeah. Angles down.
participating directly, I'm going to move you back over to the participants. Or, I'm sorry, the attendees.
Got the second device.
No, this is going to be our first one. The second is going to be a laptop.
Okay.
Thank you.
Okay, yeah, we just want to make sure that the two devices don't interfere.
Yeah, there can be some feedback.
Yeah, we'll mute the other one and close the voice and
Okay.
Okay, no, as long as you handle that, then that's fine.
Shannon, as a coach, am I supposed to be participating in any of this presentation?
Not really, no. The students should be presenting their own. So I said we're going to move you back over to this, so you're just basically being the audience in the what we call like the auditorium. There's the stage and there's the audience. So we're going to leave you in the audience. Let me see. There might be a, hold on, I'm trying to fix this login issue. I might be able to allow them to log in. I thought I allowed double, like...
Yeah, we have 2 minutes.
Maybe they're logged in directly to the laptop.
Shannon, my second team, he's only one student. He's able to log in now.
Okay. Which is that Michael or Steve?
Michael C.
Okay. Is he ready to test the camera?
Are you ready to test the camera? Okay, let me...
Okay, we'll bring him in.
Hello. Can you guys hear me good?
Yes.
Turn it sideways so we...
Oh, is it flip?
It's
Yeah,
just,
yeah,
it's
keep
90.
flat.
Yeah, there you go.
Okay.
Okay, let me try. Oh, there we go.
Yeah. Okay, there you go. Okay.
Then I'm going to be adjusting the camera because I want to get the full demonstration area in.
Sure.
Okay. No, we can see it. We can hear it. I think you're good.
And then I'm going to try, with the spare time I have, I'm going to try and set it up on my laptop as well so that I can screen share the code in the beginning. And then for the actual demonstration, I'm going to switch Wi-Fi networks to my device, and then I can continue from the demo from there, but still be able to screen share the code.
Okay.
Yeah, we've got tape lines all over the floors in our lab too. So.
Okay, but as far as switching the devices, you're gonna be in full control of that. Is that what I'm hearing?
Yes.
Okay. Okay. Yeah. If you can control your end, that's that's fine with us. Yeah.
All right. Thank you.
Okay. Thank you.
Let's see. Did I get it yet? Here, I'll turn it off.
Okay. Good. I think we have well, I mean, fortunately, it's not a super tight schedule today, so I think yeah. Yeah, we have a little bit of leeway if there's some hiccups.
Mm-hmm. There's Destiny.
Okay. So do we have all the teams? Yes?
We're bringing Dana or Dania back in.
Yeah, we just have to get the
Yeah.
two devices working.
Yep.
Yeah.
Hello, can we try the screen sharing device, please?
Yeah, hold on one second, Dania. Rodrigo, did you have a question? We could hear you saying something, but it's very difficult to hear your voice. Yes, it's very garbled. A little bit.
A little bit.
It sounds like you're very far away from your microphone. It's that's much better, yes. Mm-hmm. Okay, Dania, are you ready to try the screen share?
Yes, but can we please get the co-host and screen sharing?
Yeah, you should be able to screen share now, right, Shannon?
I believe so. I'm pretty sure all participants are allowed to screen share.
Yeah, it's working.
Okay.
Is the screen visible now?
Yes.
Okay, great.
So are you going to use just that screen for your presentation, or are you going to try to do
We're going to use the screen sharing. We're going to use the screen sharing in this device and a camera in another one.
Okay,
should-
so when that camera's logged in, I need to make sure that I know that which camera to bring over. Fortunately, there's not a lot to choose from on this side of, but we will. I want to make sure that I know which camera it is when we get closer.
Yeah, we only want to see one at a time. Is that right?
Well, no, I can bring them both in.
Yeah, but if they're both in, then you can't. It's small. They're smaller screens.
Right.
So can you unspotlight the one that's not being used, or is that too much to manage?
I can do that.
So we'll be starting with the screen sharing at the beginning of a presentation and then moving on to the camera when we're talking about the model and the project itself.
Okay.
Okay. Yeah. I think we can handle that. Yeah. So we'll only spotlight the one that's being used.
Okay, thank you very much.
Yeah. Thank you. Okay. Good. All right. So that's everyone, right?
Yes.
Okay. Well, I think we're in an uncharacteristic positions. Do we want to start early?
Let's give everyone a minute to set up, that we can get everyone to turn their screens on for the opening. I'm going to make sure that we're sharing on Facebook in just a moment.
I think the announcement did say that we would be starting at 8. So I think it's okay if we start if we're ready.
Hey.
All right, I'm going live on Facebook.
Okay, I'll start recording.
Recording in progress.
All right, can you see the screen, Shannon?
Yes.
Okay, welcome everyone. Welcome to the Robofest Online World Championship exhibition event for the senior division. My name is Elmer Santos. I'm the Assistant Director for Robofest. Thank you so much for joining us today. This is our schedule. We're going to have some opening remarks, some introductions, and then proceed right into the team presentations. We estimate will be done a little bit after 9:15 US Eastern Time. Thank you so much, teams, for checking in. Yeah, this online format for exhibitions is challenging, and we've got some sophisticated setups that everyone will see. So thank you so much, teams, for your patience and your effort. Robofest is a program of Lawrence Technological University. At this time, we have a welcome message from Lawrence Tech.
Welcome to the 2022 Robofest Online World Championship. I'm Dr. Srini Kamampati, Dean of the College of Arts and Sciences at Lawrence Technological University in Southfield, Michigan, USA. This year marks our 23rd Robofest season and our third Online World Championship. We are proud that we have been able to continue to bring Robofest to the world to these extraordinary times, and we will continue to be committed to a competition-based learning environment, however that looks in the future. Robofest is all about STEM learning. Success at Robofest requires the mastery of multiple STEM and computer science subjects, which in turn drives preparation for college classes and high-tech careers. Additionally, Robofest teaches students to develop essential skills such as problem solving, teamwork, creativity, and communication. Thank you for your participation in this online competition. I commend all of the teams and students here for being active learners and pioneers who are eager to master technologies for the future. As you may know, Lawrence Technological University was founded in 1932 with the support of Henry Ford. At that time, Ford's famous Model T factory was at the forefront of an industrial revolution that changed the world. Likewise, we are today at such a forefront of new technologies. LTU and Robofest are paving the way. Someday, I hope you will join us here at Lawrence Tech to continue to do the excellent work you're already doing with LTU's Robofest. Your efforts are advancing science and technology for solving real-world problems. At this time, I would like to thank all the teachers, coaches, mentors, and parents. You make this program possible for our students. Without you, teams do not exist. Additionally, I'd like to thank all of the inspirational site hosts and international directors who have organized local qualifying competitions or are sending teams to the 2022 Robofest Online World Championship events. Finally, we cannot give enough thanks to our local judges and LTU judges and the staff for their dedication. In closing, I wish all of you luck with your endeavors today and hope you have a great connected learning and collaboration experience through our 2022 Robofest Online World Championship competition. Thank you.
Thanks again to Lawrence Technological University for their support. And thank you to Robofest 2022 sponsors. Thank you so much. This would not be possible without your generous support. Exhibition is one of a series of World Championship events for Robofest. Please join us for the remaining events, which will be the game events in 2 weeks. Also, we'll be having our awards ceremony on May 21st. Again, my name is Elmer Santos. I am the Robofest Assistant Director. Also with us today, Dr. Christopher Cartwright, the Director of Robofest, and Shannon Polonis, Robofest Coordinator. We would also like to welcome our teams. We have 7 enthusiastic teams here with us today. Thank you so much for coming. And also we have our judges that would like to introduce our judges. First, we've got John Resner.
Oh, hello. My name is John, and I've been doing this for over a decade. So good luck, everybody.
Thank you, John. Okay, next up, we have Mrs. Pam Sparks.
Hello, friends. My name is Pam Sparks, and I am a Michigan educator. I've been educating STEM programs in Michigan for over 30 years now. I'm a huge Great Lakes advocate. And I am also a huge Robofest fan. I coach teams and I help Shannon coordinate in the Robofest office. I just was looking at the list of names and I love the creativity. I'm looking forward to some great presentations.
All right, thank you, Pam. And then last but not least, we've got Professor Destiny.
Hello, everyone. This is Destiny. I'm from the Department of Mathematics and Computer Science here at Lawrence Tech, and welcome to you all. Best in the competition.
Thank you. So once again, thank you to our judges. This program and the judge biographies will be available on our Robofest World Championship page. Okay, just want to briefly go over the process for judging and determining winners. Teams were required to provide video as well as source code. A code inspector will recommend points for the programming. Judges have been selected by the Lawrence Tech RoboFest office. At the competition, we will give the microphone to each team, put them on the stage, and each team will have 4 minutes to present and demonstrate their projects. Afterwards, judges will ask questions for about 2 minutes. Teams must use English for communications. However, translation is allowed where needed. And then lastly, judges may ask additional questions to teams after the event within 24 hours, and then teams have 24 hours to reply. Okay, this brings us up to the group photo. So we'd like everyone to turn on the cameras and come close.
All right. Still waiting for a few to get set for their photo. Kind of look at your profile picture, make sure it looks like you want it to look.
I think Eagle 4 is with Eagle 3. Is that true? So the only team that we're missing are the ladies from Saudi Arabia. Can you turn on your camera, Dania? One of the cameras so we can get a good picture. There they are.
Hey, excellent.
Wonderful, wonderful. What a great looking group. Eric, you can get in there too.
There he is.
There we go. Okay, 3, 2, 1.
RoboFest.
RoboFest, one more. Here we go. 3, 2, 1. RoboFest. Good luck, everyone.
All right. Oh yeah, just would like to note there's been a slight change in the order. Hopefully teams are aware. We're gonna start with Aerobots, and then Cornhole Railgun, and then Gigantros will be last. So hopefully that makes sense. We're gonna start with Aerobots, and then Cornhole, then Eagle 3, Eagle 4, CDS, J5 SES, then PLKCL, SCMC robotic team, and then lastly will be Gigantros. And yeah, okay, Shannon, do you want to explain how the process will work?
Sure. How we're going to do this is right now we are going to move all of the teams except Aerobots back into the attendees side. All of you are now marked as the team. So everyone with the team with an asterisk will be on hold. Basically, you'll go in, you'll see everything, but you won't be part of the screen at this time. So the Aerobots will be the only group. And then when the Aerobots are done, and the judges have asked all their questions and then they've completed their part of it, we will move the Aerobots back, and then we'll move the next team, which would be the Cornhole Railgun in, etc. down the line. So each team will just it'll just be the judges and the team in the panelist view for that presentation time. So at this point, Pam, if you can help me start at the bottom, and I'll start at the top. We're going to move all of the teams except Aerobots back to the attendees side.
All right, everyone, just give us a minute to do that.
I don't think I have host rights, so maybe Elmer.
I did give you co-host, so a minute ago. You might need to accept it. That's all right. I can. There's not that many. I can.
Are you saying you want to update the team, the order?
Yes, the team order will be.
Aerobots will be first.
Aerobots will be first.
If it is not much of a worry, each of us can just screenshot and then label them in front of us. Like if you can, maybe if it's gonna.
Yeah, we'll announce the numbers. We'll make sure everyone knows which team.
Yeah, so I don't think you should waste. You should bother yourself doing it if you do.
Okay, so I'm going to stop my video, so I'm not on the screen as well. So just the judges and the team. Eric, I'm going to move your okay. So also too, that I will be running a 4-minute timer. Since we do have a little bit extra time today, we're not going to hold you to exactly 4 minutes. So if I say time is up, then we will ask you to wrap it up. But we will, like I said, allow time for the Q&A as well as translations if required. So I will be running the timer. I'll still give you the, when you're ready to start, just go ahead and start talking and I'll start the timer at that point and I'll let you know when the 4 minutes is up. So then we'll turn it over to the judges and they'll have their time for questions and answers. So whenever you are ready, Aerobots, you are free to start your presentation. Yes. Go ahead.
Okay. Hi, I am Toño. Hi, I am Daniel. And we are Arrow Robotics from Toluca, Mexico, with the ID 2895-4. And we are here to present to you our project for Robofest Exhibition 2022. This project is an introduction to vision systems using LabVIEW.
The project scope of the fish driver. Introducing to vision system, image processing and communication protocols show a fun and interactive project for the kids. And the STEM learning goals for the project is the image processing using linear algebra, image color processing with RGB model, image morphology techniques, communication protocols, and motor control using PWM.
Now, everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing it is stupid. Albert Einstein. So, we gave the fish the opportunity to conquer the land.
That's why we reason they create the fish driver. This project is divided in 3 main systems: the vision system, navigation system, and communication system.
The first module is a vision system. The first step in this module is to acquire an image. Then we apply an RGB model to create a binary image. Then we define our target using different morphology techniques. At the end, we can track our target. The process image cannot be used as an input for the control of the navigation system.
The second model is the navigation system. The robot structure is all built of aluminum. The powertrain assemble is the battery and the motors. And the control module is the Myrion. And this gives us the navigation base of image tracking. The robot moves depending on the position in the fish of the tank.
Now, our last system. The last system is the communication system. In this, we first set up a network, then we configure our Wi-Fi camera on the top of the robot, then we connect the Mario to this network, and also we connect the computer. This gives us a wireless communication that gives the project more freedom and a more range of movement. Now, the product roadmap. We have the real-time vision acquisition and image processing, drive control based on vision system outputs, wireless connection setup between systems, and with all of this, we have a full autonomous working system. Now, while I was explaining that, my friend Daniel was controlling the robot using the security override. This allows to prevent that the fish goes into danger and it stays safe every time. But we can also switch to the camera on the top of the road that is watching the fish. Now the fish is controlling the robot. The robot is moving depending on the position of the fish, as you can see in the bottom left. And now it goes in a danger zone, so we bring it back.
Time's
back
up.
with the camera. Thank you.
Right, time for Q&A.
Hello, great project. So, when did you realize you needed an override system for your robot drive, for your fish driver?
There was some occasion that the fish run into a wall or want to jump over a step. That's why we have the override, the security override.
How long did it take you to add that feature to the program?
Basically, it's just another input from the camera, so it is really simple. Like in the first week, I don't know.
Okay, so I have to say, I love your lower thirds. Very good graphic there on your screen that we're seeing on our end. And I do have to ask, being a biologist, is what is the purpose of the fish? Does it have anything to do with like fish identification, or the fish is just your, like your canary in the coal mine, it's your example organism?
¿Cuál es el propósito de hacer el proyecto? O sea, ella como biologista pregunta lo del pez, pero dile que el proyecto, el propósito final, ¿cuál es?
Okay, the fish is now for a fun and interactive project for everyone to learn a little bit of vision system, but the true purpose of this project is to be applied in different situations, like the medical situation and controlling wheelchairs for paralytics with the iris, and more applications like that, like autonomous navigation in vehicles.
Okay, yeah, very great application of using animals to improve our technologies. Thank you, nice job.
Thank you.
Any other questions?
Yeah, please. How difficult was it for you to do this? Because is it because you use the fish as a remote control, right? And with that, I'm asking, how difficult was this project?
¿Qué tan difícil fue el proyecto? Obviamente al usar el pez se vuelve complicado, pero ¿qué tan difícil fue para ustedes?
Before this project, we developed other visions project based in the same principle, but I think the most difficult challenge in this specific project was the wireless communication, the connection between the Wi-Fi camera and the Mario and the computer, between only Wi-Fi network.
All right, thank you.
Is that the end of the question and answers? Thank you, gentlemen. All right, at this
Thank
time,
you.
we're going to move you back into the attendee side and bring the cornhole railgun team in.
Recording in progress.
There they are.
You have to do our other device.
Okay, got it.
This is the laptop.
Got it. Okay, whenever you're ready, I will start the timer when you start your presentation.
Yeah. We still need the cameras on, right?
Sorry.
Yes.
Yeah.
Why is it okay?
Okay, that's okay. Well, yeah, no
Hang on.
rush. Yeah, well, let's make sure everything's right before we start.
Yeah.
Reverse cameras. All right, you got good video now?
Yes.
Okay, audio check.
Good.
Okay. All right, I think we're ready. So tell us when to start.
Whenever they start, I will start the timer.
Hi, I'm Nick.
And I'm Maria.
And we are Team Smart Labs. We built this cornhole railgun to learn about projectile physics and to play against a robot.
We thought that
The applications with projectile physics can be used in ballistics and sports.
this was a great way to show that physics is fun and that we can learn projectile motion.
Cornhole is a fun backyard game that has recently been growing in popularity. It is played by two teams which alternate throwing bags onto a board. Each bag on the board is 1 point, and each bag in the hole is 3 points. First to 21 wins.
We know that many robots can play against humans in mental games such as chess, Go, or even Jeopardy. We thought, why not a physical game? Cornhole would be the perfect example to show that projectile motion is fun and we can play cornhole.
Here we have our 4 bungee cords that hold the elastic potential energy in the system. They wrap around these rollers and connect to a nylon cord through this adapter. The nylon cord is then tensioned with the spool, which is powered by a DC motor and a 320-to-1 ratio gearbox with an encoder. Here we have our over-center trigger mechanism that reliably holds the cart in place. When the cart is released, the elastic potential energy in the system is converted into kinetic energy and gravitational potential energy in the cart and the bag. The bag then flies off, and we need these brakes to absorb the excess kinetic energy in the cart.
This was the trick we used to find the height. We know the length is 231. So we know the height must be 231 sine of theta.
Calibrating the launch was not easy. We had to set angles from between 30 and 60 degrees and set the distance from between 120 to 150 centimeters. We then measured all the distances and calibrated the needed initial velocity to reach the targets.
This is our human machine interface. It uses the Raspberry Pi motor controllers and encoders. It can calculate how far back to bring back the bungees to hit our desired target. Actually, let's give you a demonstration. What's the height and distance?
The distance is 10 meters and the height is 1 meter.
All right, I'll plug that in.
I'll load in the bag and Maria will preload the cart.
Now I can make fine adjustments with this encoder wheel, but right now it seems pretty good. All right, launching in 3, 2, 1.
Wow, nice shot. Good thing we have physics or we couldn't miss.
Here is the program we use. We use Python. Here we import the necessary packages and define our colors. Next, we program our global variables and we start with G. This is for calculating the graphics for our HMI that I mentioned earlier. Each one of these circles represents 1/10 of a second.
And the blue circle represents the target we're trying to hit.
This is how we program to calculate the stretch for all the trigonometry needed. We use Pygame for processing the keyboard inputs. And this is where we programmed our encoder wheel.
The encoder wheel sends out two square waves that we can use to determine the position of the motor.
And this is where we programmed the graphics for the HMI. I talked to my teacher and she said that it was awesome, this project.
I spoke about it at my school too, and they said it would be a great way to learn these physics calculations, such as Newton's laws of motion.
We thought that in the future, if this were to be used in classrooms, it would be great if it were smaller and maybe a golf ball or a Nerf ball could be used, so it could be smaller and easier to use.
And this is a great project for classrooms to learn about physics in a fun way.
Time's up.
Any questions?
This was nice. This was nice, guys. I really enjoyed the presentation. The way you guys were pulling up with the slides and the interaction, the energy. Guys, I love it. This is not a question yet, but I just I couldn't hold it. I had to just give it to you. I really love it. Thank you so much.
Thank you guys very much.
Hello, I've got a couple questions. So, what was the hardest part about programming your robot?
Probably the hardest part was we had to
account for all sorts of different problems. Like, for example, like the power was too strong, and so we had to improvise by creating more supports so that it wouldn't break. Like here we had a lot of problems with it breaking and everything. So I think that was a big part.
And we also had to program the distances and figure out how to put calculations on and display them on the HMI.
You mentioned the braking thing. What kind of problems was that causing you?
Well, originally the cornhole railgun was kind of acting like a slide hammer, and it was hitting into the without the brakes, and it was hitting into the end so hard that it was making the other end come apart. So we have clips there now, and now we have brakes with some foam padding in between so it can absorb the energy.
Okay. Last question. Why did you guys decide to go with a railgun instead of something like a catapult?
We thought that it, like a catapult, we felt like wouldn't have enough, like it needed more force, we felt. So
it also, the catapult doesn't have as much accuracy. This one is easier to change the angle on and to set the distance. It's more accurate every time.
Okay. So how would you change the angle? What's the process in doing that?
You loosen these collars, and then you can raise or lower this whole machine on the PVC pipes, and then you measure the angle with a level.
Alrighty. Thank you.
Well, cornhole, just real quick, cornhole is a beloved game. Tell me about your teamwork where you're at different schools. How did you come together as a team?
Well, I would come over here on some weekends. This is my cousin, and we've been doing robotics for a while. So I come over here on weekends, and we would work on this project, and and it's fun. So.
Okay. So has the robot ever gotten a perfect score?
Yeah, we've played against the robot, and it was pretty fun, and it plays better than we can.
It can't quite get a perfect score at the pro level, but it's pretty close. I mean, because pros, they like add different kinds of spin on it, and they can determine whether they want to block the hole or what they want.
Okay. Yeah, thank you. Great application for the classroom too.
Thanks.
Any other questions?
So yeah. So we can ward off any invasion from the aliens, right? With this.
Yeah. For future application, we'll make a really big one.
Okay. So how complex or confused? What will you say this project was to you guys? How complex? How difficult?
Well, right now, I'm a sophomore, so I'm learning physics in school. So it was really interesting to see how I was learning things in the classroom and then I was also applying it here. So I think I found it a little bit easier for me to learn to apply the physics in order.
The physics were a little bit harder for me since I'm only a freshman and I haven't learned physics yet. but it definitely helped me, and I think it'll help me in the future too.
Good job, guys.
Thank you.
Thank you.
Thank you. I'm going to move you back into the panelists or attendees, and I'm going to promote Eagle 3. They're coming in so they can get everything set up.
All right. Good. Are we good? Let's turn this off.
Whenever you are ready to start, go ahead and just start your presentation. I will start the timer when you go.
All right. All right. Are you ready to start?
No, drone's
No,
not.
can you connect to it first?
I know.
Yeah. 1 second, we're connecting to our drone.
All right, drone's connected.
You're connected?
Yeah.
All right, you ready to hit run?
I am.
All right. So our project was an autonomous parking enforcement officer. The people who go around and give you tickets in the big cities. And we wanted to automate that with a drone using AI and like OpenCV camera stuff in order to read the license plates.
Want me to run?
Yeah, run it.
Okay, sure.
We only have so much time.
I know. It takes a while to start up because it has to initialize all of our variables and whatnot, as well as load the object detection model. So it'll take a while to start up.
All right. So we have a few statistics here on our poster board to really push home the fact that this is a necessary thing. And oh, there she goes.
So you can see, as the program starts, a recorder thread starts up, and it will record a few frames at a time, and record that as a video file, an AVI specifically.
And our saved video file gets sent to this computer right here, which will then read the video file, take the text out of the video file from the license plate, and then ideally 2 hours later, it'll go again, read the video again, and then it'll compare them. And if the same license plate's there for 2 hours, that means the car's been in the same spot for 2 hours, which is over the extended limit. So then they get sent the ticket. The reason we felt the need to do this with a drone, though, is because about 5% of all parking enforcement officers in the state of California, they get hit by a car or they get beat up over their job. And we thought it was kind of a big problem. And a drone doesn't have to worry about that, especially since you can't tell if the drone's giving you a ticket because it's all automated in a camera.
So as you can see, the program has now started running through the ANPR, or automatic number plate recognition.
Let's see if I can move the camera closer for you guys.
Yeah, I don't know how well you can do it, but.
You guys see that? No.
No, it's already ended.
It's already ended?
Yeah.
My apologies. But what it did there is it pulled up the video and it drew a green box around the license plate to show we detected it. And it extracted the text. All right. And we'll go again. I'll record a second video and then I'll land.
And then I'll run this through the same.
And then I'll run it through the same code again, take the video, take the text out of the video. And then if the text matches, it'll print the ticket. This is the ticket we printed when we recorded the video last time.
As an example.
As an example. It's a different license plate than the one we used here. And you want to like explain the process though, like the code?
Okay. So after the video recorder thread records the actual AVI video file, or then run it through the object detection model that I trained using TensorFlow. The object detection model will locate where the license plate is within the image and extract that region on the image. It will then take this region and actually run it through something called object character recognition, which will attempt to read the text off of the plate itself. Once we get this text, we will extract it from the list that it saves it as, and then we will print that on the terminal. As you can see, it's running through it right now.
Time's up.
Oh, time's up.
Time's up.
All right. Questions?
As you can see,
So, I am wondering if you've tried this in the field.
Yeah, that's why we got this height. This is the height of the car that we used it on. And it has worked in the field. It works with these cardboard printouts of license plates. It works with photos of license plates. It'll work with temporary license plates, like the one they issue you at the DMV that's just paper. And it'll work with the real deal.
We will work with active license plates as well.
Okay, thank you.
Is there any other questions?
Yeah, I think you answered my question while you were answering hers. But I think I like the way you guys presented, especially you that is standing like a professor, the way you were sort of making things happen, you know. I kind of like the air around your presentations. But my only concern was that the poster was a little bit too faint for me to see. So please take the camera. I want to just,
All right.
yeah, bring it closer to the camera. I want to see what's.
Yeah, can you help me hold this? Yes. All right. So let's bring this real close. Yeah, lower it a bit. So we have our title here, Autonomous Parking Enforcement Officer. We got, this is the picture of the video. You see it works with the phone as well.
You want to zoom in a little bit so we can actually
yeah.
Okay.
Basically what happened is he made an AI with TensorFlow. He made his
an autonomic number plate recognition.
Yeah,
software.
and he programmed it to read it and stuff yourself, right?
Yes.
Yeah.
I use something called transfer learning, which basically takes a pre-trained model that TensorFlow already had and leveraged it with my own images and label files, so it could specifically read license plates and read them very well.
Awesome. Awesome. All right, man. Thanks, guys.
So, how long did it take you to program this robot?
Okay, so
what do you say about?
I want to say
60 hours. It was a lot.
It was total, but if you're talking about time it took from when we started, it took about a month.
It took about a month
working.
Okay.
About 2.5 weeks for the ANPR model itself and getting the object character recognition to work, and it took another week, I want to say, just for testing and debugging.
Okay. So, what was the hardest part about programming it?
What was that?
What gave you the most problems when you were trying to program it?
The AI with the automatic number plate recognition.
It was very finicky at first until I had to retrain it once again. More license plate images and have to readjust the label files.
Okay.
And
so what was the process of?
Also gave us a lot of trouble because it uses its own module to program it, and I had to learn basically a whole new language because this thing operates on its own set of rules. That's why we had to use multi-threading to keep it alive, because it would, if it's left alone for too long, it just crashes.
Oh, really?
Yeah.
So multi-threading was a whole other pain in its own.
Yeah.
Having it run simultaneously with, or at least have it run on a different thread to actually record the file.
Yeah.
And then send it over. In a different instance.
So when did you realize you had to use multi-threading?
Well, we finished the ANPR first. So it was that last week when we were debugging and testing, we were having a problem where the drone would take off, and the second it tried to open the camera, it would drop. And after relentless debugging, we found out, oh, if we use multi-threading, we can keep it alive on one end and control it on the other, and then save it as a video file instead of keeping it live to reduce the processing power, because it would overload the drone's little CPU and crash.
Okay. All right.
That's exactly why I have a GPU limiter set up on my program as well, because it takes so much processing power off of your laptop to run this ANPR detection that I had to set a limit cap to make sure my computer did not crash while running it.
Oh, wow. How much processing power did it end up using?
I reset the timer to where it wouldn't actually stay up for that long, but I have the memory caps up to 5,120 memory. because it uses up pretty quickly.
Okay. Alrighty, thank you.
Welcome.
Any other questions?
I just wanted to ask, how would you bring this to market? Like, how close would you say this is to real implementation?
I'd say it's almost there. You stick a few variables in there so that people could alter it, and a GUI so that it could be used by the average person. And I'd say you could bring it to market with state officials right off the bat, because they could use it for parking enforcement. That's the plan.
Right, nice application. Thank you.
Thank you. I'm going to promote Eagle 4 now to the panelists and move Eagle 3 back in to the auditorium.
Oh, here. There we go.
Whenever you
And then-
begin your presentation, I will start the timer.
Going to
So-
see, is there any way you guys could put in the other Eagle 4 account as panelists as well?
Yep. The other Eagle 4 account or the Eagle 3 account?
The Eagle 4 account.
Is, what would that be named?
Wait,
Is that Mr. B or is that,
I'm wondering what I'm named as in here because my phone is now Eagle 4.
okay, so what would the other one be? What would I look for? Michael?
Michael. Yeah.
Michael, okay.
Oh, yeah, I see it.
I see it. Yep, I got you.
Got it?
There we go.
Okay.
Jones panelist. Okay, so I'm going to start. I have the screen sharing up, but I'm going to start on my phone just because of the introduction. Hello, my name is Michael C. I am here at the Eastlake Academy of Engineering. My team ID is 3549-4, and I'm here to present Current, which is an aerial medical delivery drone. So I'm going to take the camera. And you guys can hear me okay?
Yes.
Perfect. So I'm going to come over. And the problem that I've seen is that, which I don't know if this is readable, but
I think we should stop the screen share so we can see the project better.
Yeah.
Okay.
Because we're seeing something.
Stop the screen share. And then I'll re-screen share.
Yeah.
Okay, there we go.
Good.
So there's a giant problem with traffic accidents in the US, and Florida is definitely one of the higher states with driving and traffic accidents in general, but especially fatal accidents. It's not common every day to see some kind of crazy accident that's happened on I-4 or US 19, which are two extremely major roads in Florida. And a lot of those accidents lead to uncontrollable hemorrhage, which makes up 30% of total traffic fatalities. These are all problems that could be mitigated through some kind of device that could arrive before ambulances do, because the problem with car accidents is that they cause a giant traffic backup, which may cause the ambulance to arrive later and could result in some kind of loss of life. So I've implemented a drone that is in concept supposed to arrive before the police, not the police, the ambulance does. So it would arrive with a first aid kit or a defibrillator, depending on what's going on at the moment, so that it could be used with either cardiovascular problems or blood loss. The STEM principles that this concept takes advantage of is kinematics, control system theory, image processing, neural networks, and artificial intelligence. And then I also created a mock instruction manual for the drone because once it arrives at the scene, the main problem is that an area of a car accident or even the neighborhood in general, if someone's suffering from a heart attack, let's say, in their neighborhood, is that there might be debris, there might be mailboxes, there's obstacles. So the drone will arrive at the rough location using a street address, which means it would travel down the street at a higher altitude. And then it would basically just arrive on the scene, and then that bystander who called 911 would be responsible for using a simple understand UI to pilot the drone to a safer landing spot. So I have had the drone, so you wait for it to hover, and then you use your hand to control it, and it's just open or close to make the drone follow or make it hover. I also created a little Spanish undertext because Spanish is a pretty prominent language in Florida, and it's definitely the second highest spoken language in Florida. So it's important that almost everyone knows how to use it in the case of an emergency. So I'm going to pull my screen share up. All right. So, okay. What is, this isn't good. It seems like it's flashing when I try to screen share.
We can see your screen.
I think it's fixed. Yeah, but oh man. It's not. Yeah, as soon as I share my screen, it seems to flash, like it seems to flash on and off. So I think I'll try and show the code later if I can. I'm just going to go straight into the demonstration. And then I'll also try and explain pseudocode if I can as I'm demonstrating. So I think my laptop's going to disconnect from Zoom in a second. Because I'll be connecting to the drone's Wi-Fi in order to log into it using UDP.
While you're waiting, if we could go ahead and have judges ask questions while you're waiting for that to load.
Absolutely.
So judges, if you would like to ask a question now during this downtime for him, go ahead.
So interesting idea. How did you come up with the idea to use hand gestures as the main way to control the robot?
So it's been a passion project of mine for a while. And it's always been kind of like an idea to control the drone with the hand. And originally, I did use hand gestures, but the main problem was that using multiple gestures made it very hard to remember, even for someone who made it, to remember what all these gestures would do. I would do like four for forward, 3 for backward. I would do this for left and this for right. And it would just got kind of hairy at times, like trying to keep the drone from hitting a wall or something, while also remembering like, wait, I have to do this because it's not the most intuitive thing in the world.
Mm-hmm.
So I ended up taking that concept that I did early in the year and trying to hone in on the user interface portion. And so that's where I came to the idea that what's more simple than opening and closing a hand. And so the drone is connected now. If I would like to demonstrate, go ahead and move the laptop kind of over here and move this. I don't think I can. I don't want to mess with the screen share right now because it's flashing on and off, but And then I'm gonna bring the laptop over really quick because there is, wait. Let me check something.
Pam or Destiny, do you have a question while he's working
Oh,
on
there
the
we go. Okay.
demonstration? Okay.
So I first made a prompt because there have been many times while programming this where I accidentally click run or I accidentally run on the wrong program, which is this program. And the drone just starts flying and taking off and mayhem ensues if preparations aren't made. So I have created a little prompt. So if I press backspace, it's just going to close out of the code and nothing will happen. Relief will be kind of emanated that we didn't have like a false start. But if I press space, the program will start. And I'm going to start with my closed hand in front, as the instruction manual said. And the CV2 window takes about 5 to 10 seconds to load up, but now it is loaded up. I'm gonna open it. It's gonna come a little closer. I'm gonna have it do cardinal directions. So it's moving up right now. I'm gonna hold it down. Now I'm gonna make it travel downward. And then, you know, I'm not comfortable with this close space. It's too close to me. So I'm gonna use kind of force here, make it travel backwards in the Z direction. And then we'll do right and left, right, left. And then you can also do combinations because it works as a full velocity vector matrix. So I can make it go diagonal. Let's do, I'm gonna try bottom, left, and back. And see if it, yep. So it comes down, it comes left, and it comes forward. So now I'm gonna prime it for landing. Make it hover. And I'm gonna land it on this table. Needs a little bit more. Okay. So now I have thumbs down countdown. So it's gonna count down from 5. And then if I flip my thumb up, it's not gonna land. So this was a problem last time where it would instantly land if I put my thumb down, and sometimes the hand detection wouldn't be perfect if the drone was moving, and that would cause it to land spontaneously. But now it has a countdown from 5, 4, 3, 2, 1, and then my hand is not in screen. 5, 4, there we go. And that is the demonstration.
Judges, do you have any other questions?
How long did it take you to program the hand detection and all this?
Wait. The hand detection was something that we already covered last year. So training and validating artificial intelligence databases wasn't exactly out of our reach. It was definitely more of the drone part, if anything, than the AI part. But this took upwards of the beginning of the school year to now, just from like kind of a concept in the brain to reality. But I definitely had problems with, I guess, finding out where to start off and what kind of things I should use, what kind of programs I should use to run the model itself.
Okay.
I tried I tried color distortion, morphism, and I also tried just more simpler CV2 canny options, but those just drew bounding boxes around the hand. And I definitely wanted something more specific at the time because I wanted to do gestures. And that's when I landed on media pipe, which draws coordinate points based on your model at each joint in the hand. And I still use that for this project because I could optimize it and I could, it had a lot of modularity to it. So I could kind of dive into the class area and try and make it run a little faster, especially when it comes to the fact that, as Eagle 3 said, if you don't constantly send the drone commands, it is going to land. So if it's not doing anything, it's constantly being sent 0, 0, 0, 0 for X, Y, Z, and yaw velocities, just to make sure that it is not going to shut off spontaneously.
So you also mentioned that the drone itself was hard to program?
Yeah, the drone itself had some interesting quirks about it. One thing was the automatic altitude sensor inside it. No matter if you're using it through the app that it usually comes with, or if you're actually just hacking into it with Python, that automatic altitude sensor always is on, and there's no way to disable it. So in like a classroom setting with tables and chairs and other obstacles, that definitely showed to be a bit of a mess. And then if you started up the drone on like a program where it was just meant to take off and you haven't written anything yet or got deleted, you would have to basically grab it by the guards and flip it over because that instantly turns it off.
Oh, okay.
Okay, judges, we're going to have to move on. If you have any additional questions, we will email them to you for response. So at this time, I'm going to move Eagle 4 out of the panelist view and move in Collegio CDSJ5 SES from Hong Kong. Whenever you are ready to start, I will start the timer. So just go ahead and start your presentation when you're ready.
You guys okay? All right, let's go.
So, hello everyone.
Hello, judges. We are students from CDSJ5 from Macau. My name is Mario.
My name is Wilson Chan.
I'm Wilson Lai.
My name is Brian Guo.
Raymond Fong.
So because the Macau government is still enforcing the zero COVID law, so right now when you come to Macau, you have to stay in quarantine facilities. So in this phenomenon, these facilities accommodate people with risk of carrying viruses. So this means the staff working inside may have a high risk of infecting these viruses. So to minimize the contact between the staff and the inhabitants, we came up with an idea of using robots to replace duties which require most contact with the patients. So for example, delivering food and cleaning up rubbish in this case. So let's start the demonstration.
As we can see that there are 3 rooms and the remote controls for each of them. Now, firstly, we will have the delivering food to the rooms 1. To start the robot, we will need to press the buttons on the remote controls first. And then we will need to start the deliver foods. And now the robot is going to the rooms 1 and given the foods for the user to wait them to taking in. While the robot is serving the rooms, the other remote controls are disabled, so the next users need to raise the robot to finish their own current task first. Now the robot will return back to the standby.
So let me explain a little bit. So actually, we are simulating a situation where there are multiple rooms, and in this case, there are 3 rooms in this site. So there is one remote control inside each of these rooms for the user to use the robot. And now we have a second scenario. So as you can see here, we have a bag of rubbish in room 2, and it's waiting for the robot to collect it. So here we have a close-up of the remote control room 2. And now we select collect rubbish. So now let's start it over again. So now it's going to room 2. Like that. Okay, so that's all we have for our presentation. Thank you for listening.
Judges, do you have questions?
Yes, I do. Guys, thanks for the presentation. What will you say is maybe some kind of training you've gotten maybe from mathematics, physics, computer science that you use in this project?
So in this project, the most important feature we use is Bluetooth connection and a series of logic processes. So for example, so those 3 remote controls are actually connected to the robots by Bluetooth, and there are some logic and variables that has to be used to determine which room should the robot go to, and what the action should the robot do. So for example, if it's delivering food, then other remote controls cannot do anything when the robot is in motion, and the robot must make sure that it is delivering food, not doing another action.
So who is supposed to do the programming? Like who will instruct the robot to move and do a particular activity? Is it the patient or the administrator?
So if you mean by who controls the robot to move, so it's actually the user who uses the remote control. He can just make the robot move by pressing a button to instruct what the robot should do. And then the robot will automatically go to the specified location.
Okay. How far, sorry, I think I'm taking all the questions. How far can the Wi-Fi connection go?
So in this case so the site is only about a few meters long, but actually I think it can reach about more than 10 to 15 meters.
All right, thank you.
So you have an impressive group there. There's 5 of you. So how was it? Who did what? Was it hard coming to a agreement on what you were going to do?
Sometimes. So actually, at first we have to practice how to master using this robot and just try to cooperate well to distribute different work efficiently.
Okay, well, you showed very well. Congratulations.
Thank you.
Any other questions we'll have to send through email? We need to move on to the next group. Thank you.
Thank you.
Whenever you're ready, go ahead and start.
Yes, we are ready.
Okay. Go ahead.
Good morning, everyone. We are KCL SCMC Robotic Team 1 from Polanco Centenary Li Xiucheng Memorial College, and this is our design, the ping pong ball washing machine. It's our honor to present these details to you all. This is Anki.
This is Andrew.
This is Braden.
Inspired by the restrictions in table tennis competition at 2020 Tokyo Summer Olympics, we designed this machine for table tennis athletes since it can assist the organization of table tennis competition and solve the hygienic problems associated with COVID-19. Our aim is to eliminate the obstacles concerning the disinfection and cleaning issues of sports equipment that have retarded the progress of sports promotions.
Let us demonstrate how our machine operates. When the switch is turned on, 2 servos will control the arm with a basket containing the table tennis balls to return to its original position. All the data will be reset. The movement of the arm is controlled by the cooperation of 2 servos. One is for horizontal movement and one is for vertical movement.
The table tennis balls will be soaked into baking soda solution and Dettol respectively. After pressing on the start-stop button, the LCD monitor will display all the necessary statistics, including model information, pH status, number of balls added, and humidity of the fan balls. The weight sensor is used to measure the number of balls in order to prevent overload or the situation that no ball is put before the soaking procedure starts.
The procedure will only start when the weight sensor measures 1 to 6 balls. The humidity in the fan balls is sensed below 80%, and the pH of the baking soda is measured alkaline. The pH meter is installed to monitor the pH value of the baking soda. Baking soda is used for removing greases and dirt, while the table tennis balls are soaked into Dettol for the elimination of virus and bacteria.
The table tennis will be eventually carried to the fan box for drying. We have attached heating tubes to the fan so that a more ideal drying temperature can be provided. The drying process will be finished when the humidity has decreased by 5%. After the table tennis balls are dried up, the arm will carry them back to their original position.
We use Arduino as our programming app. Concerning the weight sensor, we created a field algebra to let the sensor automatically deduct the weight of the basket at the start of the procedure, no matter how heavy the basket is. Therefore, the machine can still measure the number of balls despite the actual weight or the position of the basket.
So now let's introduce our program. For the do-while structure, If the final humidity is lower than the initial one by 5%, the fan and heating tube will stop working and the basket will return to its base. Otherwise, the fan and heating tube will keep working and measuring the humidity every second until the requirements for returning to the base are satisfied.
We have also installed a button. If the measured pH is not alkaline or if the number of balls add in is null or more than 6, it will not be suitable for the machine to start. It will be displayed on the LCD monitor to remind you to change another tank of solution or check if there are suitable amount of balls added. If you still want to start the progress, you can press the button again to start anyway.
For better demonstration of the returning progress, we will now accelerate the drying procedure of the table tennis balls by drying it artificially. Our components, including the fan blocks, the containers, and the arms, are created by 3D printing techniques. We first drafted out our design, and then we printed it out with a 3D printer. Our other components are created by cutting arcadic boards into a required shape by laser cutter. This is all of our presentation. Thank you for listening.
For questions and answers?
So,
yeah.
Oh, John, go ahead, please.
Go ahead, Destiny.
No, go ahead, John. Go ahead.
Okay. How did you come up with 5% humidity being necessary for optimal drying?
Because we have measured it for several times, and after a few experiments, we tried 2%, 3%, and 4%, just in similar ranges, and we found out that after the humidity of the sensor in the fan box has decreased by 5%, the table tennis balls are nearly all dried. So we take this value in our program. Thank you for your question.
Thank you.
Thanks, John. Thanks, John. Hey, guys, this was a good one. This was good. So did we see the demonstration of the project apart from the drying? Did you play or where's the sport activity here? Like, I'm trying to find where the sport stuff comes in.
Mainly we use table tennis ball as our project's target because it's small enough and it is easy to do our experiments on. But with further development, instead, many of the other sports can be used in our program for disinfection, such as tennis balls or golf balls, badminton balls, or even non-sports equipment, such as some tablewares in restaurants or pens used in public examination sites can be used as the target of these disinfection machines.
Okay, so disinfection. All right, thanks.
One last quick question. Can you tell me about your QR code?
Yes.
Yes. You can. Do you want to know the contents of the QR code showed inside the?
Like, how would you use the QR code?
Well, the QR code is our
poster, video, and
it's all our content of our machine.
Yes.
So maybe you can scan it and look for it.
Okay, one quick question, please. What empowered you to do this? Like your mathematical background, computational background, physics background, chemistry, biology, which area?
Our sports teacher actually complained about the problem in this pandemic that they cannot play this table tennis very conveniently because of the policy that our government broadcasted.
We need to have some disinfection machines for cleaning the table tennis balls. So in this machine, we applied some biological knowledge, such as the baking soda and the Dettol solution. The baking soda solution can clear away the dust and greases attached on the table tennis balls, and the Dettol solution can just eliminate the viruses. Furthermore, for physical knowledge application, in the fan box, in fact, we have some heating panels so that to increase the temperature inside the fan box for better drying.
Thanks. Thank you.
Very nice. Thank you. Well, we're going to come in with our last team. We're going to promote. (3713-1). You need to accept the panelist invitation in order to bring you over to the panelist side from the attendee side. Is there a different device that we should bring over? You are, there a different device? I know sometimes when you log off and log back in. Here, let me bring you over, Dania. Sometimes it renames you back to your original and I can't find you, so.
You found the one though, right? The
Well, there's two. There's Dania and there's a camera device.
Right.
And okay. I've promoted them to panelists a couple. Yeah, you have to actually
good.
accept the invitation to become a panelist. Okay, here we go.
Okay, good.
There we go. Okay.
Hello,
Okay.
can you hear us? Is everything clear?
We can hear you.
Okay. Oh, 1 second. The camera has flipped. 1 second.
Whenever you're ready to start, just go ahead and I will start the timer. This is our last presentation of the day. Thank you all for joining us. Well, when you're finished, go ahead. We'll have some announcements and wrap up, but go ahead whenever you're ready.
Okay, so first of all, we'd like to introduce ourselves. My name is Tabahat Al-Saad, and I'm the team's graphic designer, Lego, builder, and robotics engineer. I'm Rima Wamdi. I'm a graphic designer, researcher, and programmer.
I'm Riyad Khalid, and I am the engineering and the mechanical of the vehicle and the prototype.
And our lovely coach is Dania Basahi. We love to thank her for helping us throughout our technical difficulties. Assalamu alaikum, first of all. Hope you all are having a great day. And I'd like, as we introduce you to our names, we'd like to introduce you to the meaning behind our prototype's name or the entire project. So, Riyad, can you please bring me so the reason behind its name and mostly its shaping and design overall is because of an ancient monster called Gigantros. It's a gigantic monster that legendary cannot be defeated unless put to sleep because of how powerful it is. As well as the name gigantic, which means other than strength and prominence, means unusual or exceeds the usual. And we can also add to that our team name, which is Gigantros. Adding the row kind of means
the successes in a row that our team will hopefully be achieving. And that's how we get our team name and our vehicle. We'd love to introduce you to our research problem and how we solve it. Danny, can you move the camera with me, please? Can you flip the camera so you can see better?
Can you stop the screen share for just a moment so we can see your demonstration up close?
Okay, yeah, sure. As you already know, we had an accident with our project, and this is what we kind of had to do with solving it. So first of all, I'd like to zoom in on our little city right here and talk about our problem. Our problem is actually the usage of fossil fuels and natural gas and other non-renewable harmful materials in sea transportation, and how it can badly pollute the sea and make it harder for marine investigations in future scientific research. So as well as the long durations it takes cargo and sea transportation to be, which mostly has led us to unnecessary human resource consumption, such as excessive food, excessive oils, and other things that we can really cut off on. So what we did to try and solve it is we created a fully automated seaport that uses renewable energy sources, such as the ones displayed right here. Here we have 3 types of renewable energy sources. First of all, we have hydroelectric power. Give me a second, I'll talk about the other one while the power is on. We have also solar power and wind energy represented right here. Now we will share screen because our sun has set anywhere we are. It hasn't set, but it's not powerful enough for the solar cells. So here the solar station power uses LEGO renewable energy kit solar cells to power a motor, just to show that it can be used as kinetic energy for future uses. Is the screen share there? One sec. Okay, so this is a representation of its movement in the sun. And now moving on to the other energy types. We have wind energy using turbines here, and this Heron's fountain using physics mechanisms. This Mr. has a lab coat and a tie right here. This uses conservation and conversion of kinetic energy to potential energy in water systems to be able to produce a fountain to power this lovely device. And this in its turn shows us how we can use hydroelectric power to move things such as this hydraulic lift right here for this house. And then moving on to talk about our marine system and the transportation vehicle system right here.
The vehicle transportation system starts upon the launch of the artificially intelligence drones that specify the optimal route for the self-driving car, for the self-driving vehicle, to find the perfect destination. After that, it goes with that path to the smart seaports and the designated destination. When it gets to the smart seaport, which is represented in this model, the vehicle like this starts here. The sensor detects its presence and moves it into the garage. After that, starts a collaboration between artificial intelligence and Internet of Things to check the vehicle condition. After that, send a report to the operation manager. So as you can see, we had a working prototype before, but after the water incident, the sensors are no longer working, so this will not be powering today. This is the garage, by the way. It was like moving and opening and closing like this. And what we'll be moving today is our prototype. And since our little pool wasn't working before, we're going to use the house's entire pool, so hopefully that's better.
Okay, and now I'm going to talk about the vehicle. The real vehicle can use in more than one field. We can use it in travel and transport, and entertainment and tourism, marine rescue and search and exploration. And it has 2 powerful, compact, high-speed electric motors and can go to 2,000 horsepower. And the battery has capacity for 4,000 kilowatt non-static battery. And now we're gonna show you the prototype. Can you hold on?
The vehicle's design is used to be streamlined and to resist fluid movements for optimal speed. Can you tell us a little bit about its motors and how it works?
Okay, it had a motor and a servo. It has battery. It's 7-volt, and the servo can control 3 channels and control all the things inside. And that's it.
Here we have a Lego prototype that we built before the actual one, and that was used in our previous design, but now we've upgraded to this one. We are done now, and if you have any questions, please do ask.
Thanks, guys. Oh, I should say, beautiful ladies. Thank you so much. Beautiful, intelligent ladies. That is awesome. Thank you so much. So this system you have is controlled from the tower, or does it? I mean, the tower means the base. Is it controlled from the base? You're on mute.
Yeah, sorry. The tower is actually a marine system that's used for navigation, mostly for the vehicle. The actual controlling system is in the garage, and the transportation system in the wheels of the system shown before.
Okay, so let me call it a robot. The robot is able to make decision while in the water, right?
Yeah, the drone that is accompanied by it actually flies alongside the vehicle, and then it can detect the best route for optimal destination reach and lower accidents by other types of objects in this way.
So we have 2 systems in one.
Yes.
So if I'm going on a cruise, this robot is always hovering around us, and then the cruise is going, and the what do you call it? Yeah, is the drone is hovering over us, right?
Yeah, I can have some stops for recharging, of course, but yeah, its main focus is to optimize route detection for the vehicle.
So just in case, if the drone has issue, it means we that are cruising are in trouble, right?
No, actually, the cruise actually has a preset path that is kind of average for every ship to go in when it's trying to reach that destination. The drone's job is to offer additional help to it. So if there's a storm, if there's an unexpected iceberg, if there's anything else like that in its way, it can actually navigate around it and help reach the passengers and the cargo safely.
Okay, so there's a default route somewhere. Because I don't want to get lost in the sea. So now I'm more convinced. Now the next question is, what sort of empowered you to do this? Is it the mathematical skills you ladies have, or is it the physics intelligence? Which of the area of science empowered you to do this?
First of all, pardon me for answering most of the questions, as my friends here are not fluent in English, so I'm trying to kind of help around here. But like we do have very good teamwork, actually. So actually, the idea to work in our to use this problem and solve it actually came from our unique abilities. So Eliada here can do great job with motors and robots and can create amazing prototypes as the one you saw before. Ranim here is a great programmer and robot builder, and we both graphic design and do research for the team. So first of all, we tried to come up with a great background for the idea. So our idea got inspired of 2 different things. So first of all, the legendary monster, as we said before, and second of all, we found actually that Tesla uses very similar navigation systems and motor uses and mechanisms for its vehicles. And we related that ocean and sea transportation share many of the same issues that land transportation did before Tesla existed. So we thought to ourselves, why don't we apply similar ideas to sea transportation to optimize that as well? Thank you.
Okay, do you have questions or should we follow up with emails and keep moving? I mean, we're at time right now.
I just want to quickly say congratulations for persevering.
Thank you.
So sometimes that happens, right? That's how progress happens, is things fall apart and then we just keep moving on. So good job persevering.
Thank you very much.
Okay, if the judges have any additional questions, we will send emails to the coach.
Sure.
Thank you very much. So
Thank you
at
for
this
having
time, we're going to, should we put everyone back in attendees? Elmer?
Yeah, sure. Sure.
Okay.
Is that okay?
Yep.
Okay, why don't you bring everyone in? We'll just make some concluding comments. Yeah, so yeah, again, yeah, thank you to all the teams.
Recording in
Having to do
progress.
a live presentation and then having to work through all the challenges of doing things online. So all teams did an outstanding job. As Shannon said, teams may receive follow-up questions by email, and then they'll have approximately 24 hours to respond. And then after that, the judges will finalize their judging, and the results will be announced at the online World Championship closing ceremony on May 21st. Details or how to join are on our website, so please join us for that. And I think we're up to the point for some closing remarks from Dr. Cartwright. So let's bring him on.
Okay, thank you, Elmer. Okay, so I'm Chris Cartwright, Director of Robofest. Thank you everyone so much for your participation in this online format of Robofest competition using real robots. I'd like to thank all the coaches, mentors, parents, students, and judges. Special kudos to the Robofest staff, Shannon, Elmer, and Pam. I was impressed today by all the creative applications of robots to various challenges in the 21st century. For instance, using things like vision sensors, Wi-Fi communication, physics, drones, text extraction, artificial intelligence, food delivery and rubbish collection, disinfecting table tennis balls, and smart cities with renewable energy and autonomous vehicles. Again, everyone deserves a round of applause. So we'll see everyone on May 21st at the closing and award ceremony. Goodbye.
All right, thank you, everybody.
Thanks, everyone.
Yeah. Thank you.
Everyone. Thank you.
Awesome.
Good job. So impressive.
Thank you.
Thank you, everyone.
Goodbye.
Yeah,
Bye.
Thank you, everyone.
Thank you very much, everybody. Have a great day.
Bye.
Bye, everyone.
Pásenle la cámara aquí porque traigo fotos. Sí. Buenas. Hola, muy buenos días a todos. Gracias por estar aquí el día de hoy con nosotros. Agradecemos haber estado en la transmisión que nosotros presentamos a Arabot Robotics. Ellos son el equipo de Arabot Robotics, el equipo de avanzados, y presentaron un proyecto que se llama Fish Driver. Toño y Daniel llevan un tiempo trabajando con nosotros. Y cuéntenos, ¿qué les parecieron los proyectos que ven el día de hoy? Hubo proyectos muy interesantes como el de los drones y otro que estuvo muy bien explicado que fue el de la catapulta, del cálculo de trayectoria. Esos me parecieron muy interesantes. Estuvieron buenos.
En mi caso, yo opino lo mismo. Estuvieron muy interesantes los dos. Ver sus resultados y ver cómo lo explicaban era muy llamativo la forma en cómo lo daban a entender.
Muy bien, ¿quisieran decir algo más al público o con eso todo está bien? Gracias por vernos. Gracias. Pues no nos queda más que dar las gracias a todos, gracias por estar con nosotros, gracias por vernos. Arabo Robotics se despide. Les recordamos que tendremos la categoría de Game el día 13 de mayo, donde pues estaremos usando una de las mejores competencias que tiene Robofest Internacional. Entonces los vemos el 13 de mayo. Recuerden que la siguiente semana las competencias son por video, donde no las podremos ver, únicamente los jueces de Estados Unidos calificarán. Les agradecemos mucho, gracias por estar con nosotros y nos vemos. Hasta la próxima. Adiós. Adiós. Muchas gracias. Hasta luego.
Thank you.